This is the Dr. Pi channel. Welcome everyone to this week's important semiconductor news from May 31st to June 6, 2025. We've got, well, quite a stack of sources here covering the industry's pulse just from the last week or so.
Yeah, quite a bit happening.
Everything from market numbers, global policy shifts, some really cutting-edge tech breakthroughs, and of course the usual corporate moves. Now, if you're navigating this space, maybe as an investor or an industry professional, you know how vital it is to get straight to the most impactful information.
Absolutely. There's just so much noise out there.
Exactly. So our mission in this deep dive is to, well, cut through that noise and deliver exactly that for you, drawing everything directly from this material we have in front of us.
And what these sources really show, I think, is a snapshot of an industry that's definitely in high gear. But it's also grappling with some pretty complex external forces.
High gear, but complicated.
Right. They show us the underlying health, which looks robust, but also all the strategic maneuvering and, the sheer pace of technological evolution happening all at once. Connecting those dots, that's where the real insight is, I think.
Absolutely. Couldn't agree more. So let's start by grounding ourselves in the latest numbers. What do the most recent reports in our sources tell us about the current state of the global market? Are things still looking strong?
From the data we have here, yeah, market health looks quite robust. The Semiconductor Industry Association, SIA, their figures show global semi-sales hit $57 billion in April 2025.
$57 billion for April.
For April. Now, put that into perspective. That's nearly a 23% increase compared to April of last year, 2024.
Wow. Almost 23% year over year.
Yeah. And even looking month over month, sales were up 2.5% from March 2025. So still climbing.
Okay, 23% year over year growth. That's seriously impressive. It doesn't just feel like a bounce back. It feels more like a strong expansion phase, right?
It does.
And what about the equipment side? Because that often gives us a bit of a forward look at, manufacturing confidence.
Right, the CapEx side. And those numbers, they really reinforce that picture. Semi reported that global semiconductor equipment billings, they hit $32 billion in Q1 2025.
$32 billion in Q1. How does that compare?
Well, that figure represents a 21% year-over-year increase compared to Q1 of 2024.
Another 20+% jump.
Exactly. So manufacturers are definitely spending heavily on the tools they need to build out capacity and, develop those next-gen capabilities.
Okay, let's unpack this a bit. For someone trying to understand where things are heading or maybe, planning their own capital expenditures, what do these combined growth figures really signal? What's the takeaway?
I think they paint a pretty clear picture of strong, sustained market demand right now. That nearly 23% jump in sales, it confirms chips are moving off the shelves in, significant volume.
Right.
And the parallel 21% growth in equipment billings indicates that this isn't really seen as just some temporary surge.
Okay, so the confidence is there for the longer term.
It seems so. Companies are making these long-term investments in fabs, in infrastructure, signaling, pretty high confidence that current demand isn't just going to continue, but it's going to require substantial future capacity expansion.
So if you're planning CapEx.
If you're planning CapEx, these numbers basically validate the need to invest pretty aggressively just to stay competitive and capture that future market share. And for investors, it suggests the revenue growth potential in the sector remains very much intact.
That clarity from the numbers is definitely helpful. Now, here's where it gets, as you said, complicated, maybe really interesting. All this growth is happening against a backdrop of some pretty intense policy and geopolitical activity. The sources talk about some significant actions regarding the U.S. CHIPS Act. What's developing there?
Yeah, this is a major story from the past week based on these sources. It seems the Trump administration is reviewing and actually renegotiating semiconductor grants that were initially awarded under the Biden administration's CHIPS Act.
Renegotiating.
Okay. And Commerce Secretary Howard Lutnick is quoted directly in the source material stating that some of these grants struck them as, and this is the quote, overly generous.
Overly generous, huh? That's strong language. Does that mean actual deals could change or even be, scrapped entirely?
Well, the sources do indicate that the possibility of canceling certain deals is on the table, yes.
Okay.
But the administration's stated goal, at least as reported, is focused on enhancing the value of these agreements. So the implication is they want to get more perceived benefit or, let's say, efficiency from the public funds being allocated.
Right. Getting more bang for the buck, so to speak. And is there specific strategic motivation mentioned behind this review? Why now?
Yes, one key strategic objective that's highlighted in the sources is the administration's desire to ensure the U.S. maintains more than 50% of global AI computing capacity. That's a stated goal.
50% of global AI compute. That's ambitious.
It is, and this renegotiation seems to be happening partly due to concerns, specifically noted in the source, about the sale of advanced AI chips to foreign nations, like the UAE, for instance.
Ah, okay.
So it suggests the potential link between these grant reviews and an effort to control access to the most cutting-edge AI capabilities.
So it's directly connected to that bigger picture of AI dominance and national security concerns, perhaps.
Yeah.
How might this uncertainty around the grant renegotiations impact the companies that were, counting on that funding?
Well, it inevitably creates uncertainty, doesn't it?
Mhm.
Companies that base their investment plans, their expansion timelines, maybe the scale of their projects on specific grant amounts now face potential delays or changes to those plans.
Right, throws a wrench in the works.
It can. While the stated aim is enhancing value, the process itself, the review and renegotiation, it can slow down progress and fundamentally alter the economics for these firms. It definitely adds a layer of risk to investing in U.S. semiconductor manufacturing right now. It could potentially make some companies a bit more cautious until the revised terms become clear.
That makes perfect sense. Stability in funding is almost as important as the funding amount itself sometimes.
Exactly. Predictability matters.
But this policy activity, it isn't just confined to the U.S., is it? The sources point to other global strategic moves, too.
Oh, absolutely. If we connect this to the bigger global picture,
Yep.
we see various nations really trying to position themselves strategically. Mexico is particularly active, according to a Milken Institute report mentioned here.
Mexico. What's their angle?
They're pushing hard to become a key player. They're leveraging their, strategic location, their access to critical minerals, and a growing talent pool in STEM fields.
And I think I saw they have a specific target.
Yes, President Sheinbaum's Plan Mexico. It's quite ambitious. It aims to double Mexico's semiconductor exports by 2030.
Double by 2030. Wow.
Yeah. And this clearly aligns with those global trends around nearshoring and trying to build more resilient supply chains. It's a direct response, really, to recent geopolitical dynamics and supply chain disruptions.
We also saw mentions of maybe smaller scale, but still significant international cooperation, like Guatemala and Taiwan.
Right. They inked a deal, according to the sources, aimed at boosting Guatemala's IC capabilities. And Europe's continuing its efforts, too. Spaceforge, for example, opening an office in Portugal as part of a broader plan that includes European semiconductor manufacturing plants.
So these examples, even if smaller than, say, a giant new fab project, they show this distributed effort, right? Building up local ecosystems.
Exactly. They are indicative of this worldwide effort to build or strengthen local semiconductor capabilities, often leveraging specific regional strengths or, like Guatemala and Taiwan, fostering international partnerships to get there.
And shifting gears slightly to a more, let's say, contentious point mentioned in the sources. China responded this week to those accusations from the Dutch defense minister about espionage targeting the semiconductor industry.
Yes, the sources report that China explicitly rejected those accusations. Their position, as stated in the material, is that its advancements in the semiconductor sector are homegrown, not the result of stolen intellectual property.
Okay, so that's their official denial.
That's the denial and counter-assertion presented in the source material. We're just reporting what's there, of course. But it's definitely another clear example of the heightened geopolitical tensions that are playing out directly within this industry.
Okay, so recapping this part. We have strong market growth happening alongside this really intense policy and geopolitical jockeying.
Yeah, that's a good way to put it, jockeying.
What's fascinating here, I think, is how policy and geopolitics are so directly shaping investment and expansion strategies, continent by continent, which raises a really important question. How do these national strategies align with the underlying technology trends, the things that are actually driving the market growth we talked about earlier?
That's the crucial intersection, isn't it? And the sources are absolutely clear on this point. The primary, almost overwhelming force driving the semiconductor industry right now is AI, artificial
What
intelligence.
comes up everywhere?
Its explosive growth is mentioned repeatedly across these materials as the major catalyst for fundamental shifts, not just in demand, like needing more chips, but in how chips are designed and manufactured.
Yeah, it's not just about needing more chips. It's needing fundamentally different kinds of chips, isn't it? Or at least different ways of building them. And the sources highlight how this is impacting the actual technology development.
Exactly right. One huge area being transformed by AI is packaging, advanced packaging.
Packaging, okay.
With traditional process node scaling just making transistors smaller, becoming increasingly difficult, and frankly, more expensive, advanced packaging is now critical.
Why critical?
Well, the sources, especially some of the Chinese excerpts we looked at, emphasize that it's becoming a key enabling technology because it allows us to overcome some of those scaling limitations and integrate more complex functions onto a single package, even if not on a single monolithic chip.
So things like chiplet design, that
Yeah.
seems to be everywhere now. Breaking down a big chip into smaller, sort of specialized chiplets that get connected.
Precisely. The sources note that chiplet design is may not replacing entirely yet, but certainly complementing and in some cases gradually replacing the traditional monolithic architecture. It's seen as a way to boost computing power, improve manufacturing yields, which is huge, and potentially lower costs by mixing and matching chiplets.
Mixing and matching, like chiplets made on different process nodes,
Right.
or even by different companies.
Exactly. That's the flexibility it offers.
And the sheer diversity of AI applications,
Yeah.
from massive data centers to self-driving cars, smart speakers, all those edge devices the sources mention, that's also accelerating this need for a more modular chiplet-based approach.
Yes, absolutely. Different AI tasks need different kinds of processing power and memory access. Modular design, facilitated by chiplets, allows for more customized solutions to meet that diversified demand much more efficiently.
Makes sense.
And the sources also point out another critical factor, the cost, both in terms of energy and time of moving data around, whether it's within a chip or between chips. That's becoming a huge bottleneck.
The data movement problem.
Right. And this further underscores the value of advanced packaging techniques, things like 2.5D or 3D stacking, that can place compute and memory components much closer together physically. Minimizing that data travel distance saves power and boosts performance.
And we know the big players, TSMC, NVIDIA, Intel, they're all pouring massive resources into this packaging space, right?
Oh, absolutely. They're all mentioned as making huge investments and competing fiercely in advanced packaging technologies. They clearly recognize its central role in enabling future AI performance gains.
Speaking of TSMC, their technology forum was a big highlight in the sources this week. What were the key takeaways from their event? What's their perspective?
Well, unsurprisingly, TSMC heavily emphasized AI's role. They stated pretty clearly that AI applications are driving the entire industry's growth trajectory, and they made a really striking projection.
Which was?
They expect the semiconductor industry to reach $1 trillion market size by 2030.
$1 trillion by 2030.
That's their forecast, and it's heavily predicated on this continued massive expansion of AI.
Wow, $1 trillion. That's a bold forecast, and it really speaks volumes about the scale of opportunity they see being driven primarily by AI.
Right.
What specific technologies did they showcase at the forum?
They highlighted advancements across both their leading-edge process nodes and their packaging solutions. This included updates on their M3P and N2 process technologies, which are coming soon, and specific mentions of next-generation offerings like A14, N2P, and something called SOWX for packaging.
Okay.
There was a really strong focus throughout on high-performance computing, HPC, and also on improving energy efficiency across the board, which is absolutely critical given the immense power demands of these large AI models.
Definitely. Did they announce any specific new nodes?
Yes, they specifically announced their A16 technology, that's Angstrom 16. It's designed explicitly for AI and HPC applications, and they're planning volume production for 2026.
A16 is specifically for AI HPC, hitting volume in 2026.
Huh?
Okay, that puts a pretty concrete timeline on their next bleeding edge offering for this really crucial market segment. And what about their packaging efforts? You mentioned SOWX.
Right. Their 3D Fabric packaging technology platform is advancing, and they specifically highlighted System on Wafer, or SOWX. This seems geared towards achieving, well, ultra-high levels of computing integration, essentially enabling the creation of those incredibly dense and powerful AI processors we were just discussing, putting huge systems onto a single wafer-level package.
Incredible integration.
And one other thing the sources noted was their commitment to sustainability goals. They're targeting 100% renewable energy use by 2040 and net zero emissions by 2050. They positioned this as an integrated part of their long-term strategy, not just an add-on.
Good to hear. Okay, so it's clear the foundries like TSMC are pushing the envelope hard.
Yeah.
But beyond the giants, the sources also mentioned some specific AI-related platform and technology announcements from other players too. ARM, for instance.
Yes. ARM unveiled something called its AI-defined Xena Compute Subsystems Platform, or CSS. This looks specifically aimed at accelerating software and silicon development for the automotive sector.
Automotive AI, that's a huge growth area.
It really is. And the Xena platform seems quite notable for that space.
What makes it stand out?
Well, it's described as a pre-integrated, pre-validated, optimized platform. It features 16 of their Cortex A720AE cores, which are specifically tailored for automotive workloads like ADS, Advanced Driver Assistance Systems, and also IVA, in-vehicle infotainment systems.
Okay, so specialized cores. What else?
It includes critical safety and security features, which are paramount in automotive. Things like CPU coherency, chip-to-chip connectivity for linking multiple SoCs, an optional image signal processor, and importantly, flexibility to integrate customer accelerators or partner IP alongside the ARM components.
And ecosystem support. That's always key for ARM.
Absolutely. The fact that major EDA tool vendors, Cadence, Siemens EDA, Synopsys, are already supporting it is really key for enabling rapid adoption and ecosystem development around it. It's a very clear sign of the industry creating these targeted, pre-built solutions for specific high-growth AI markets like automotive.
Right, moving beyond just offering IP cores to offering more complete subsystems. And we saw other AI-focused tech announcements mentioned, often linked to funding rounds, like an analytics processing unit.
Yes, SpeeData got funding for its APU aimed at data center and cloud analytics acceleration. And Edge Cortex raised money for an energy-efficient Edge AI chiplet focusing on generative AI inference and, interestingly, on-device learning.
On-device learning at the edge. That's significant.
It is. These highlights really show the breadth of hardware innovation needed for AI, everything from the highest performance gear in data centers down to extremely power-efficient chips for edge devices.
And there was that collaboration too, Siemens and others.
Right, the collaboration between Siemens, Cadolto Data Center, and Legrand Data Center Solutions. They're designing a modular edge data center concept that can apparently scale from basic workloads all the way up to high-density AI-powered computing. It really shows that cross-industry effort needed to build out the actual physical infrastructure for AI, especially at the edge.
It's just compelling how much AI seems to be reshaping the entire stack, from materials right up to data centers. But the sources also included some, let's say, more fundamental materials and process breakthroughs this week, not just AI-specific hardware designs. IMEC had some interesting news.
Indeed. IMEC, working with Ghent University, announced what looks like a significant step forward in high-speed signal processing. They reported the first fully integrated microwave photonics chip fabricated entirely on silicon.
Microwave photonics on silicon. What does that entail?
Well, this chip apparently incorporates all the essential photonic components, modulators, filters, detectors, even integrated lasers, all onto a single silicon substrate using standard manufacturing techniques.
And why is integrating all that photonics onto silicon so important? What's the big deal?
It's really critical for pushing the boundaries of high-speed communication and sensing. By using standard silicon manufacturing, you get the potential for much higher data rates and better energy efficiency compared to traditional electronic methods. And crucially, you can potentially do it at the scale and cost needed for mass adoption.
So, potential applications.
Think much faster data links within AI clusters, advanced radar systems for automotive or other uses, high-frequency wireless communications. It's a foundational technology that could enable a lot down the road.
They also had news related to interconnects, did they? The tiny wires connecting things within a chip.
Yes, that was presented at the IITC conference. IMEC showed work on 16-nanometer pitch ruthenium, that's Ru interconnects. They managed to achieve a record low resistance figure of 656 ohms per micrometer.
Okay, 16-millimeter pitch ruthenium low resistance. Why is achieving low resistance with ruthenium important at these tiny dimensions?
Well, as chips keep shrinking, the traditional copper interconnects that carry signals get incredibly thin, and their electrical resistance shoots up dramatically. This causes performance bottlenecks, heat problems, higher power consumption. It's a major limiter for scaling.
Right, the resistance problem.
Exactly. So ruthenium is being heavily explored as a potential replacement for copper, especially for these critical local interconnects at very small pitches, like 16 millimeters and below. This result from IMIC demonstrates that Ru can achieve low resistance and is potentially scalable.
And they mentioned a semi-Damascene process.
Right. They achieved this using a cost-effective semi-Damascene manufacturing flow, which is optimized for advanced nodes like A7, so 7 angstroms, and beyond. Using semi-Damascene is significant because it's potentially simpler and cheaper than the complex dual-Damascene process typically used for copper interconnects at larger nodes. That makes ruthenium look more attractive for high-volume manufacturing.
So it makes ruthenium a more viable alternative.
It strengthens the case, yes. They also mentioned future work exploring other techniques like pillar-based structures and special epitaxial roof films to push that resistance even lower. These might sound like very small technical details, but they are absolutely fundamental innovations required to keep scaling chip performance and power efficiency, especially for the demands of the AI era.
So when you put all this together, the focus on advanced packaging, chiplets, integrating photonics, exploring new materials like ruthenium for interconnects, what does this tell us about the direction of fundamental innovation in semiconductors?
It really shows us that the industry is innovating hard on multiple fronts simultaneously to meet these massive demands from AI and high-performance computing. It's clearly not just about shrinking transistors anymore, not by a long shot.
Right.
It's about how you package them, how you connect them efficiently, both electrically and optically, and what materials you use right down at the most fundamental levels. That's where the future performance gains and, frankly, the future value creation are happening in the semiconductor industry right now. Understanding these technical shifts, even at a high level, is really key to making informed decisions, whether you're investing capital or planning your company's R&D roadmap.
That really connects the dots well, from those big macro trends like AI dominance right down to the material science on the silicon level. Okay, let's shift focus now, maybe to the more immediate corporate activity. The deals, the funding rounds, the market indicators that give us a different kind of insight into the market's dynamics. The sources noted Broadcom had earnings this past week.
Yes, that was noted in the material we reviewed, just the fact that it happened. No details provided, though.
Got it. And there seemed to be a fair amount of M&A activity captured in the sources as well.
Definitely. A few interesting ones stood out. AMD acquired Bream.
Bream, what do they do?
They're a startup specializing in compiler technology and AI software optimization. This looks like a pretty strategic software acquisition for AMD.
How so?
Well, Bream's tech basically helps optimize the AI inference, stack the software that runs AI models to work more efficiently across different hardware platforms. This directly supports AMD's goal of competing more effectively in the AI market, particularly against NVIDIA. It makes their hardware potentially easier and more efficient to program for AI tasks.
So expanding beyond just the hardware silicon into those crucial software and optimization layers needed for AI.
Exactly. That software ecosystem is critical. Then AS Media acquired TechPoint for about $390 million.
TechPoint.
They develop high-definition video transmission chips. So this acquisition clearly expands AS Media's product portfolio and their market reach, particularly in video interfaces.
Okay. And we also saw continued consolidation, it seems, in the quantum computing sector.
Yes, 2 deals noted here. Pascal acquired Aponix, and IonQ completed its acquisition of LightSync Technologies. These suggest that players in the still-emerging quantum field are actively looking to consolidate capabilities and accelerate their development through acquisitions, buying expertise and IP.
And a form factor, they provide test and measurement solutions, right? They made a significant purchase.
They did. They purchased a $55 million manufacturing site in Texas. This signals a pretty significant strategic expansion of their physical capacity, likely anticipating, or maybe already responding to, increased demand for the crucial test and measurement services needed throughout the increasingly complex semiconductor manufacturing process, especially with things like advanced packaging and chiplets.
Right. More complex chips need more complex testing. Were there any notable collaborations highlighted beyond the ecosystem support we talked about for ARM's Xena platform?
Yeah, a couple. GCT Semiconductor reached a deal to integrate Iridium's NB-IoT satellite technology into GCT's chipset, so combining cellular and satellite communication capabilities on one chip.
Interesting convergence there.
And perhaps more relevant to our earlier discussion on advanced packaging, TFI and Heisler Semi announced a joint venture. This venture aims to provide an integrated process flow covering everything from wafer production through TSV formation, through silicon via formation, and the final packaging steps.
An integrated process flow from wafer straight through to advanced packaging. That sounds directly related to streamlining these complex manufacturing steps we were talking about.
It absolutely seems to be. It likely reflects efforts within the supply chain to bring these complex advanced packaging process steps, like those involving TSVs, under a more unified operational control. The goal would be to improve efficiency, boost yields, and shorten the time to market for these advanced packaged devices.
Makes sense.
And as we touched on before, that Siemens, Cadolto Data Center, and Legrand collaboration on the modular edge data center is another good example of companies from different sectors needing to team up to actually build out the physical infrastructure required for AI deployment, particularly at the edge.
Okay. And we also saw several companies announcing funding rounds in the sources. Always interesting to see where the venture money is flowing.
Yes, a number of interesting funding announcements. SpeeData, they secured $44 million for their Analytics Processing Unit, or APU. That's focused on accelerating data center and cloud analytics workloads. So another angle on optimizing compute specifically for these really data-intensive tasks.
Okay.
Edge Cortex raised 3 billion yen, which is roughly $21 million, for their energy-efficient Edge AI chiplet. That one's designed for generative AI inference, and that on-device learning capability we mentioned shows continued investment interest in the low-power Edge AI space.
All right. Any others?
Accelercom raised $15 million. Their focus is on 5G NR-PHY IP, that's the physical layer IP, specifically enabling communication between standard phone handsets and space-based satellite networks, tapping into that growing satellite communication market and its potential integration with terrestrial 5G networks.
Direct-to-device satellite comms. Got it.
And finally, Inflection raised a pretty substantial round, $100 million. They're working on scaling their atom-based quantum platforms for applications in computing, sensing, and precision timing. That large funding round signals pretty strong investor confidence in their specific pathway within the broader quantum technology landscape.
Yeah, $100 million is significant. These funding rounds really offer a useful view into where venture capital and private equity see high potential for future growth and innovation within the wider industry ecosystem, don't they?
They absolutely do. It's a good leading indicator sometimes.
Okay, finally, the sources also included some specific market reports on certain segments, looking beyond just the overall sales numbers. What do we see there?
TrendForce reported on the global DRAM market. Now, interestingly, revenue for Q1 2025 was $27 billion, which is actually a slight drop of 5.5% compared to the previous quarter, Q4 2024.
Huh. A quarter-over-quarter dip in overall DRAM revenue. That seems slightly counter to the strong growth elsewhere.
It does. However, perhaps even more interestingly, TrendForce also expects pricing for DDR4 memory, which is the older standard, not the latest DDR5, to actually rise in the coming quarters.
Okay, wait. Overall, DRAM revenue dipped,
Yeah.
but they expect prices for the older DDR4 to go up. What might explain that divergence?
Well, it could be influenced by a combination of factors. Maybe suppliers are adjusting production mixes away from DDR4, leading to tighter supply. Or perhaps there's still persistent strong demand for DDR4 in specific legacy systems, certain industrial applications, or even some price-sensitive consumer markets, even while the newer, more expensive DDR5 adoption continues in high-end segments.
Interesting dynamic.
It is. It's definitely a detail that memory buyers and suppliers would be analyzing very closely for their inventory planning and pricing strategies.
I bet. What about materials?
TechSet provided forecasts for a couple of specific materials markets that are critical to semiconductor manufacturing. They project the global market for electronic gases, things like nitrogen, specialty gases, will reach $6.3 billion this year. That represents a solid 4.8% year-over-year increase.
Okay, steady growth in gases.
And they forecast an even stronger growth rate, 10%, in the market for semiconductor plating chemicals. They expect that market to total about $1.19 billion this year.
10% growth for plating chemicals. And the source links that growth directly back to something we discussed quite a bit earlier, right? Advanced packaging.
Absolutely, and this is a really great example of how all these different pieces connect. TechSet explicitly states in the report that the growth in plating chemicals is largely driven by the increasing use of copper pillars, microbumps, RDLs, that's redistribution layers, and TSVs through silicon vias, all key features used extensively in advanced packaging.
So it's a tangible link.
It's a very tangible link. The surging demand for advanced packaging, which itself is driven primarily by AI's needs, is directly translating into increased demand and significant revenue growth for the specific materials, like plating chemicals, that are needed to manufacture those complex package structures. It really shows the downstream ripple effect of these big AI-driven tech trends.
Yeah, that's a great illustration. So these deals, these funding rounds, the specific market reports on things like memory or chemicals, they give us a really granular view, don't they, into which specific technologies are attracting capital, where companies are choosing to physically expand, and the relative health of particular segments within the broader industry.
Exactly. It helps connect those big picture trends we started with the overall market growth, the policy shifts down to the specific actions and indicators happening on the ground. They are the tangible evidence, really, of the strategies and the technological shifts playing out in the market day to day.
We've certainly covered a lot of ground in this deep dive, just pulling it together. We've seen clear, strong market growth driven unequivocally by AI demand. We've seen a very dynamic, sometimes unpredictable global policy landscape that's actively shaping where and how chips get made. We've explored the critical technological advancements happening at the foundational levels in packaging, in materials, in specialized platforms like ARM's Xena or photonic integration. And we've seen a very active corporate environment with strategic investments, significant M&A, and substantial funding rounds.
And for anyone involved in this industry, whether as an investor, an engineer, or a strategist, seeing how these different layers interact, the market, the policy, the tech, the corporate moves, is just absolutely essential. The sources this week really reveal a market that isn't just expanding. It's fundamentally redefining itself under the immense pressure and also the immense opportunity presented by AI. We see governments actively attempting to steer this transformation. We see companies innovating right at the very edges of what's possible. And we see capital being deployed based on projections of future AI needs.
It's a genuinely complex ecosystem, isn't it? With so many powerful forces at play simultaneously.
It truly is. This intricate dance between national strategy, intense global competition, and the relentless, almost insatiable pace of AI-driven innovation. It isn't just shaping the semiconductor industry as some kind of standalone sector anymore. It is fundamentally reshaping the entire global technological and economic landscape itself.
That perspective really ties it all together, doesn't it? Looking beyond just the industry itself.
And perhaps the most compelling question, the final thought maybe to leave everyone with, is how this complex interplay, this dance between policy intent, capital allocation, and pure scientific advancement, how will it actually play out in the coming year? That's what everyone watching this space is trying to figure out.
Indeed. A fascinating question to ponder. Thank you for joining us for this deep dive into the semiconductor news from the past week, drawn directly from the source materials you provided.